Water is a religious ritual and entertainment, medicine and nourishment, energy and industry, conflict and social unrest. It crosses all borders between ecosystem, industry, economy, and society. While water is an incredibly simple molecule, it is also an incredibly complex system in the particular role that it plays within almost every major biological and industrial process on the planet. It is the most essential infrastructure to our economies. When regions have fresh water, their economy tends to improve dramatically. Agriculture flourishes. Better healthcare can be provided at hospitals and clinics. More jobs are produced. And the level of poverty typically diminishes greatly. Through the natural hydrocycle, water is a truly global entity with global consequence. But our water needs are a distinctly local phenomena. There is no global market and very little international exchange of the substance. Water is always relative to quantity, quality, space, and time. Though the total amount of water on this planet has never changed, the nature of that water, where it lies, its quality, and how we access it, is a dynamic system that changes over time. At the turn of the 21st century, we are facing an unprecedented global water crisis. Around the planet, from China and India, to the Middle East and North Africa, to California, to Chile. A number of major factors are converging, such as growing population, an increased global middle class of consumers, urbanization, aging infrastructure, depleted aquifers, and climate change. All are interacting to put unprecedented stress on water supply systems around the planet. Water supply and demand are quite simply diverging, leaving us with a projected gap in supply of 40% by 2030. It is projected that by 2025, half of the world's population will be living in water-stressed areas. At the same time, many people already live without adequate water provision and risk of diseases. Added to this is climate change that will deeply affect our current water systems. Everything from where rain falls to the chemical makeup of the oceans is in flux, and our water supply systems will have to adapt to this changing context, while at the same time providing more people with less reserves of water. These changes are forcing us to ask some very difficult questions about how we are going to avoid scarcity and conflict in the coming decades. In response to this, solutions are emerging, both technological and institutional. But they are as yet very much piecemeal, when what is needed is a paradigm shift. In order to achieve the radical jump that is required, we need to start to see the issue on the systems level, to be able to piece all these parts together into a more coherent framework. Before anything, solutions to the challenge of water will require recalibration of how we contextualize the issue. The water crisis is not a crisis of scarcity, it is a crisis of management. There is clearly no shortage of water on this planet. What there is a shortage of is effective systems of organization for managing the provision of that water. What this means in more practical terms is that our focus will have to shift from looking at water sources and volume of input to the internal organization of water networks and how to develop systems of organization that can achieve a radical jump in the effectiveness with which we use water. There is a vast opportunity for this given the nature of our current water supply systems. In our paper, we present a set of solutions built upon the framework of integrated water resource management, a new paradigm in the management of water systems that takes an integrated systems approach, an approach that shifts our current model of top-down management within a centralized linear system to a bottom-up distributed non-linear model. This approach shifts water management from a centralized model of professional organizations, pushing out solutions to disenfranchised end users, to instead building collaborative platforms that identify and engage all stakeholders. IT-enabled collaborative platforms are used to turn end users into prosumers, to create connections and transparency through the exchange of information, to enable synergies across the water value network. This approach aims to reduce the silos between organizations and the strong divide between producers and consumers, enabling systems-wide integration, collaboration, and synergies. Out of that, solutions will emerge. Integrative water management is a paradigm that can help water supply systems evolve along a number of important dimensions required to meet the needs of this new context. A key limitation to current water systems is their centralized architecture. Although distributed on the global and national level, local systems still have a centralized pattern of organization. This centralized model, although it has certain advantages, equally creates bottlenecks, dependencies, and transport inefficiencies. Integrative water management promotes a more distributed architecture. In the distributed systems model, water infrastructure for both the provision and treatment of water are positioned close to points of demand, and nonlinear cross-linkages within local networks of exchange are enabled. Services traditionally provided by a single centralized system are instead delivered via a diverse set of smaller systems adapted to local condition, but equally connected into larger networks to transfer resources across broader geographical areas as required. Our current linear model, where water passes from high to low quality in a single direction along a straight line, makes little differentiation among quality of water and different water requirements, which creates large inefficiencies through lack of reuse. In the coming decades, water systems will need to evolve into a more complex form that incorporates the non-linear connections required to enable reuse across the water supply lifecycle. What is currently a monodimensional system with respect to water quality will become increasingly multimodal, capable of a much more subtle differentiation between water qualities, and able to match those to the required needs. Reuse and recycling will be widely employed as we begin to understand and manage water, not in terms of quantity, but in terms of quality. Managing it across many different quality levels during its life cycle will be central to creating a water quality cascading model that is capable of delivering multiple usages before needing to be fully recycled or disposed. Water needs to be redefined not only in terms of quality, but also in terms of access and function. We are moving into a services economy where the only thing that matters is function and access to that function. The services concept helps us to focus on the fact that people don't want water or water supply systems, they want the services that they provide. A committed focus on access and delivered outcome is another dimension along which radical improvements in water efficiency can be achieved. Water networks of the future need to be based around performance, functionality, and actual delivered outcomes. As in other areas, this will require business model innovation for water providers. To switch to an as-a-service model, requiring them to move from selling water en masse in volume to defining what exactly the end user needs are and how to deliver that while relentlessly trying to deliver more functionality with less gross input of water. Finally, agility is becoming a core capability for many enterprises, and this will be particularly true for water providers. Water systems around the world are deeply embedded within and dependent upon their natural environment. With climate change, this enabling context is changing in ways that we are far from fully understanding or capable of predicting. Within such a context, water supply resilience through agility should move to the forefront of future water system requirements. Information technology will play an important role in enabling agile infrastructure. The Internet of Things is set to place sensors and actuators throughout water supply networks, while big data and advanced analytics enable us to cross-correlate information from many sources and turn it into actionable insight. This allows providers to become preemptive instead of reactive, making systems smart and capable of reconfiguration in order to adapt to changing events. But simply placing IT on top of existing inert monolithic systems is a temporary solution. In the long run, water supply systems need to be built through a more modular distributed architecture that enables them to truly embed this new capability into their structure, becoming more flexible and resilient. Water, being deeply interconnected with almost all aspects of economic development, is both one of the greatest opportunities and probably the greatest threat to global economic development in the 21st century. On the one hand, the water crisis is a threat, as it has the capacity to trigger rapid socio-political instability like almost nothing else. And in water's crucial role as part of the energy-water-food nexus, it is at the heart of a broader ecosystem of environmental challenges. On the other hand, the water crisis can be seen as a huge opportunity to focus resources and innovation on a major leverage point to global economic development. Providing clean, safe water to the millions of people who currently lack it has huge potential to improve the standard of living and productivity in places where it is most needed. Solving these water crises has, in the past few decades, gone from being the domain of charities trying to patch things together into a world of social businesses. As water scarcity and water value increases, this will create business opportunity that previously did not exist. All these factors lead to the conclusion that water, in all its different shapes and forms, may just be the greatest investment opportunity of the 21st century. Their economy tends to improve dramatically. Agriculture flourishes. Better healthcare can be provided at hospitals and clinics. More jobs are produced. And the level of poverty typically diminishes greatly. Through the natural hydro, water is a religious ritual and entertainment, medicine and nourishment, energy and industry complex system in the particular role that it plays within almost every major biological and industrial process on the planet. It is the most essential infrastructure to our economies. When regions have fresh water, conflict, and social unrest, it crosses all borders between ecosystem, industry, economy, and society. While water is an incredibly simple molecule, it is also an incredible cycle. Water is a truly global entity with global consequence, but our water needs are a distinctly local phenomena. There is no global market and very little international exchange of the substance. Water is